Synthetic division is a shortcut way to do long division, but it only works if we want to divide by something like x plus 3 or x minus 5, something where this is a factor and we have a 0 that goes with it. So we've talked about factors and zeros before. If x plus 3 is a factor, the 0 that goes with it is a negative 3. And this is actually, the negative 3 is actually what we have to use when we're doing the synthetic division. So synthetic division is the same as synthetic substitution, which if you look that up in an earlier section, the process is the same. But it's one of those like shortcut kind of ways where we do a few smaller calculations and it gets us to the same end result as if we did the maybe more tedious long division. So here's how we set this one up. We're dividing by x plus 3, and so the 0 that goes with that is a negative 3. So we're going to do negative 3 here, and we kind of do our division thing upside down. And then instead of filling in with this whole term, we just fill in the coefficients in order of terms with highest exponent to lowest. So pretty much in the way it's given. So 3x cubed plus 17x squared plus 21x minus 11. Okay. So we just plug those in. The first thing we do is we just bring this number down, so we have 3. When we get a number on the bottom, we take the negative 3 and we multiply. So negative 3 times 3 is a negative 9, and that goes there. And then we add down. So 17 plus a negative 9 gets us a positive 8. We take that 8, multiply by the negative 3. Okay? So the negative 3 times 8 is a negative 24. 21 plus the negative 24 is negative 3. Negative 3 times the negative 3. So again, we go back to the far left. That negative 3 times the negative 3 we just got, that's a positive 9. And negative 11 plus 9 is a negative 2. And if you go, we did this exact same example. We did this example on the long division video. If you look up at that example, you will probably see the minus 9, the minus 24, and the 9 that were all subtracted. They're the opposite signs of what we had, but we see some of those same values. And then you also see the 3, the 8, the negative 3, and the negative 2 was our remainder. So to fill out what this divides to, we divided x cubed, so our leading term was 3x cubed. So dividing by an x, we know it drops a power. So we're going to have 3x squared plus 8, okay, plus 8x minus 3, and then this was our remainder. That's our remainder, so that still has to be divided. So a negative 2 still has to be divided by the x plus 3. Okay. And then here's the interesting thing. This negative 2 is also not just the remainder, but if we were to plug in a negative 3 into this equation, if we were to do 3 times negative 3 cubed plus 17 times negative 3 squared plus 21 times negative 3, minus that 11. If we were to plug in a negative 3, we would get out -2. So this is called synthetic division, but it's also called synthetic substitution because we could use this to evaluate a polynomial like we did in, I think it was section 2. Yeah, it was in section 2 that we evaluated polynomials. So we could also use this to plug things in and see what we get. And the reason this is helpful when it comes to solving polynomials is if this comes out to a 0, then we know that what we just plugged in is a 0. And if it comes to 0, we don't have a remainder, and that piece divides out evenly, and we can use that to factor. Okay? So going forward, we're mostly going to be interested in the times where this remainder is 0. But for now, we're just still practicing the dividing and seeing what we get even with that remainder. Okay, so let's move on to our next example. So here we have x cubed minus 3x squared minus 7 divided by x minus 4. So again, what's the 0 that goes with x minus 4? The 0 with that is a 4. So that's what we're going to use in our synthetic division. So we're going to have 4 here. And then we have 1x cubed minus 3x squared. And again, we're missing the x term. And we need to hold that spot. So we need 0x minus 7. And then we do the same process. We bring this down, and you can still think of that as adding down because we have nothing there. So 1 plus that nothing is 1, right? And then we do 4 times 1, so we multiply. So 4 times 1 is 4. Add it down, so -3 plus 4 is 1. And we multiply again, so 4 times 1 is 4. Add down, 0 plus 4 is 4. Multiply, 4 times 4, 16. -7 plus 16 is 9. So we started with x cubed, so now we know once we've divided, we're going to have x squared. So we have 1x squared plus 1x plus 4. And then this guy's our remainder, so that 9 has yet to be divided by x minus 4. So that's the polynomial that we get. Well, I guess it's not a polynomial because of this remainder term. But that's what we get when we divide x cubed minus 3x squared minus 7 by an x minus 4. But the more important thing is, since we have this remainder, since it does not divide evenly, that tells us that 4 is not a 0 of that polynomial. And that's kind of what we're going to use going forward. But that's synthetic division, which could also be called and used as synthetic substitution.